Hey there! Ever wondered how we discovered the tiny building blocks of the universe? Today, we're traveling through time to uncover the story of the atom. Our story begins over 2,500 years ago in ancient Greece. Back then, some philosophers had big questions. What is everything made of? Many believed the world was made of just four elements: earth, water, air, and fire. This idea came from thinkers like Empedocles and later became super popular because of Aristotle. They thought everything we see was just a mix of these four elements in different amounts. But not everyone agreed. Along came Democritus, who had a totally different idea. He said, "What if everything is made of tiny, invisible particles you can't divide any further?" He called these particles atomos, meaning uncuttable. Democritus' idea was groundbreaking. But here's the catch. He didn't have any proof, just his imagination. For centuries, people stuck with the four elements theory instead. Fast forward to the 1800s, when science started catching up. A chemist named John Dalton brought Democritus's idea back to life. He discovered that matter is made of tiny particles called atoms, and each element is made of its own unique type of atom. But Dalton thought atoms were just solid balls, like marbles. Turns out, they're a lot more complicated. In 1897, a scientist named J. Thomson discovered something surprising. He found tiny, negatively charged particles inside the atom. These were called electrons.
He came up with this discovery by using an experiment called cathode ray tube, which is a sealed glass tubes from which most of the air has been evacuated. A high voltage is applied across two electrodes at one end of the tube, which causes a beam of particles to flow from the cathode, the negatively charged electrode, to the anode, the positively charged electrode. The ray can be detected by painting a material known as phosphors onto the far end of the tube beyond the anode. The phosphors spark or emit light when impacted by the cathode ray. To test the properties of the particles, Thomson placed two oppositely charged electric plates around the cathode ray. The cathode ray was deflected away from the negatively charged electric plate and towards the positively charged plate. This indicated that the cathode ray was composed of negatively charged particles.
Thomson thought atoms looked like a plum pudding, with electrons stuck in a positively charged soup. Sounds tasty, but he wasn't quite right. Next up, Ernest Rutherford. In 1911, he ran an experiment shooting tiny particles at gold foil. Most went straight through, but some bounced back. Weird, right? Rutherford realized atoms aren't solid. Instead, they have a tiny, dense nucleus in the center, with electrons orbiting around it, like planets around the sun. Then came Niels Bohr, who gave us a clearer picture. He discovered that electrons don't just orbit randomly, they move in specific energy levels. This became the Bohr model. Finally, scientists like Erwin Schrödinger and Werner Heisenberg gave us the modern quantum model. Electrons don't move in perfect paths, but form a cloud around the nucleus, the electron cloud. So there you have it, the amazing story of how we discovered the atom. From ancient ideas about fire and water to cutting-edge science, it shows how curiosity helps us uncover the secrets of the universe. Thanks for watching. And remember, every discovery starts with a question. What will you discover next?